Thanks everyone for joining this session of LangChain in Action, crafting innovative LLM powered applications. Uh, Quick about me, I think we already covered that part, so I'm just skipping this slide. Before we get started, a small disclaimer. All views expressed in this presentations are my own personal opinions and do not represent my employer's view in any way. Okay, so this is the high level agenda for today's session. Very importantly, we'll start with why LangChain. Um, if you all are convinced the importance of doing this now, then probably will love its components. And I'm planning to conclude this session with expert of this technology. But I came across this, I loved it, and my intention is share the joy with you all. I hope at the end of this session, some of you will really find it useful, and they will create or even contribute to this open source framework. So that's an idea. So let's get started. Uh, I hope most of you who have joined this session are already aware of the generative AI boom, right? Uh, Most of you must have tried somewhere down the line to just to understand out of the curiosity to see how the technology is moving. You must have tried some of the applications like ChatGPT or Bard. So typically, yeah. So typically, as a consumer of this newly coming technology, what currently are we doing is, as an end user, we have large language models which are trained by bigger companies. We have API access to them, and these models are trained on humongous amount of data. And what are we doing is we are firing some queries and we are getting the response. So text in, text out, kind of a typical application, right? And you'll see that without the training on anything, without spending much efforts, you are getting answers of what people are using it um, to learn their subjects. Developers are using it to get the code snippets. There are so many applications. People are writing blogs. I'm not going into that. The beauty here is these all models are trained on public available data sets, right? So if you move from consumer applications to enterprise application, right? So, okay, I'm liking what is happening, but what if I want to ask queries on some of the documents that are private, that are with me, and those documents are not publicly available? So if I fire some query related to those document or that kind of an content, will this LLM models answer the questions? Probably not, because they are not trained on such kind of a document or that kind of a data, right? So when we move from consumer to enterprise kind of an application, there would be so many use cases where data is not publicly available, but still you want to leverage this technology of LLMs for your applications, right? if if you want to do something like that, and LangChain is not limited for that use case, but I'm just telling you, as a name suggests, the center box of all these kind of an application could be your favorite as a LangChain. What it will do is it will take a large language model. You can index your private document, allow user to fire a query with an interface, and it will not only generate the responses on your document, but you can have an action. Probably then an action could be sending an email of that. An action could be completing a payment. An action could be uh, flight booking. An action could be hotel table reservations done and all that stuff, right? So what LangChain allows you is to take the power of LLM, connect with your internal data, and then take meaningful action out of it. So if you really want to use this technology to be in place in enterprise application or in an end-to-end useful applications, probably you need a center box, and that center box would be a LangChain, right? So let's understand how a LangChain will do. Now the question is, uh, can't I do it on on myself, like why I need another third party kind of a software. So let's take an example. So I'm giving you a use case. Like imagine your boss or somebody ask you to create an application. There are business users, they don't understand SQL, they don't understand query language, but there is a data, sales data somewhere lying. And what they say is, hey, I don't like to code anything, I'll just type this is what I want, I will ask a question in natural language, you should go and fetch a data for me. Not only fetch it, you create a visualization for me and you present it on my screen so that I can understand very well, right? So in this case, there are multiple operations that you have to do. Okay, what could be the multiple applications? One is, okay, the first step is to understand the natural language, understand the intent, what actually end user wants to do. Once you understood that intent, probably to fire that query to a database, maybe you have to create an SQL query out of it. Then that query has to be correct. You cannot have to have hallucination on the query. So you have to test that query, then you fire that query, then you got the results. On that results, you need to do some post processing. Again, you have to call some external API or visualization tool to create some visualization. And again, you want to connect it to some of the downstream applications for displaying the results, right? So there are many things that you have to do. It's not just a calling one LLM, right? So what I'm showing you on the screens are, very few examples of how these can be done. Like you can have an end LLM and then multiple language models you will use for different tasks, or you can do it in a sequential manner, like one LLM. First LLM will understand natural language, then there would be a natural language to SQL, then that SQL will file to database, and then parsing, then visualization. Many things have to be done, right? So do you think that doing it every time for every use case, writing all this glue code, uh, don't you think it's very troublesome, right? And that's why LangChain has a superpower, right? So before we deep dive into what LangChain is all about, just I'll give you an example. Okay, so here is a website, and that website is called as the 2023 mad MLAR data landscape. Okay, so this is just 2023 landscapes, and you can see that so many tools are mentioned here, so many tools, right? And in that so many tools, if you want to look for where the lang chain is, probably here is a lang chain, right? So you may have a question in mind. There is plethora of tools here. This is overwhelming. This is actually a mind-blowing, set of tools and everything. What is so special about LangChain and why I should invest even this 60 minutes today, and if you probably some more time after this. So this is a link. Firstmark.com, mad.first. And here I was talking about this plethora of tools that you're seeing here, and LangChain is one of the component. Okay, so the question still remains, like what's so special about it and why I should be investing learning this tool into that. Let's move to our slides. So why LangChain? Okay, first thing is to enable LLMs to interact with external systems. As you know, just an LLM, like firing a query to LLM and getting a response, will not help me to complete end-to-end applications, right? I have to have an ability to connect to some of the public data sets, private knowledge repositories. I should be able to call some other APIs. I should get data from other applications. Even when I get an answer, I should have an ability to check for the truthfulness. I should be able to get that data verified from something like Google search or some other kind of applications, right? So unless and until you don't get this ability to connect all these peripheral devices, you will not be peripheral applications, you will not be able to create a complete uh, application, right? There is very interesting line which says that, if you want to make LLMs data aware and agentic, LLMs will come. So what does that mean is, uh, your model should understand, reason, and use data to take an action. It's not just I fired a query and I got a response, right? At the right side, you will see the popularity of this tool. Till June 23, you can see that uh, already 40K stars crossed on GitHub. So super popular uh, repo. Okay, so let's understand, what is so special about it. Okay, let's understand what LangChain is all about. If you ask me in one liner, it's an open source developer framework for building LLM application through composability. Now, composability is an amazing aspect, and all this session will understand that why it is so popular into this. Okay, uh, in a detail, eventually you can say that LangChain is not an LLM. Okay, LangChain is an interface to variety of different foundation models. So from LangChain, you can use ChatGPT and OpenAI models. You can use Google Palm models. You can use many other. I will go into detail. So it's an interface to all these models, right? It has a lot of components, and we'll spend good time on that. What are those components are? um, it will help you to manage your prompts, and very importantly, it's a center interface, and we have seen in the previous diagram the center interface for memory, for external data to other chains, and very importantly, the last aspects of this is agents and tools. So this is at a center what LangChain is all about. It's a framework, it's an open source framework. Um, and this slide probably will give you, and again, uh, this is getting continuously upgrading, so it's not static. You may see some more components coming up, but at a high level, LangChain has these components. So let's spend some time on it. So the first component of LangChain is models. What type of a models you can for on which LangChain provide the interface to it. So you have LLMs, you have chat models, embedding models. In the prompt, you have a concept of templates, output parser, or example selectors. We have indexes, we have chains, we have agents, and memory. And this all is covered under a single tool called LangChain. And I guarantee you that you'll enjoy this by looking at the simplicity of this. It's not a rocket science. Though it covers so many aspects around LLM, it is super easy to use. Okay, so let's deep dive into each of these components one by one, and then probably we will actually see some of the hands-on uh, fun things about these things also. I will not be keeping it a theoretical discussions. So a first component about models. So let's understand, what type of a models are supported by LangChain. So by type of a models, at a high level, there are proprietary foundation models. Okay, what do you mean by foundation models? So those are pre-trained LLMs generally owned by large corporates, and they just expose you an API. So proprietary means you don't know actually what is, they are not open source, but they will expose through via API. So one of those is like an OpenAI for, you can use ChatGPT, GPT-3, or you can use Google's Vertex AI, Palm kind of thing. So obviously you have to have an API key, and you have to pay as per your usage, but they will open this, you can use this, model trains on huge, like billions of parameters. And I'm sure you must have, played with these models to see this. The another type of models are called as open source models, but still those open source models are so huge, and in order to produce outcome from this, you have to host this somewhere. So instead of you hosting those, you have, options like Hugging Face Community Hub. So from Hugging Face, you can still access those open source model, but still they are managed by Hugging Face or hosted on Hugging Face hub. And there are third types of models, which probably right now we may not discuss, is those who are shared as in pure weights. Models are shared as a trained weights, and that you can use. So let's move and actually see the examples how that look like. Uh, so models. Again, if you want to use with OpenAI, you have to have an OpenAI API key. How to get an OpenAI API key is right now it's not in the scope of this discussion, but it should be super easy and you can get it. So if you want to use LangChain with OpenAI, what you need is just from LangChain import OpenAI, and then you can say that LLM is equal to OpenAI, and you can start using uh, OpenAI models. If you want to work with Hugging Face, again you need an Hugging Face API token, and that hundreds of models are hosted on Hugging Face hub. So which repo exactly you want to use it, the ID of it, and then you can say that LLM Hugging Face that you can use. Today in this discussion, I'm going to show you all the demonstration using Google's Vertex AI. So Vertex AI is a managed machine learning platform by Google. So what you need to do is you import LangChain, and what you need to do is from google.cloud import a AI platform, that is Vertex AI. On your Vertex AI project, you just need to enable, on your GCP project, you just need to enable Vertex AI API. If that Vertex AI APIs are enabled, you can directly start using this. So what I'm doing here is the first model is called as an LLM model. I'm just saying that LLM is equal to Vertex AI. Model name is text bison. And these are some of the parameters that you can set about the tokens and temperature. Again, going to the details of this parameters is not in the scope, so you can go with the default parameters as well. So this is how you choose what LLM model that you want to use. So I have used a Vertex AI text bison model. Once you have that, you can directly say that LLM and you fire your queries. The way you were firing those queries on web application, you can simply say that, hey, write a blog on Sachin Tendulkar, right? So it's Sachin Tendulkar is my favorite player, and this is the blog directly written by the model. And I think you must have played with all this. So this is how you used LLMs via LangChain by different interfaces. If you want to use chat models, then what you need to do is just say chat is equal to chat vertex AI. So this is more designed to have a interactive kind of an application like a chat experience. So here I'm saying that chat is equal to vertex AI, and in the chat I'm just sending. So here you have an option saying that system message. So what kind of a chatting it is. So you tell the system saying that, hey, you are an helpful AI bot and mostly designed for a study plans. So based on your application, you can give that system message. And then I'm writing a message called, hey, I would like to learn machine learning. How should I do this? And this is a question that I am asking, how can I learn machine learning? And it is giving me an answer that there are different ways to learn machine learning and popular ways, course on a subject, and all that details, right? So we saw LLM, we saw how to use chat model, and there is very exciting type of a model is called embedding. I'm sure you are aware of what do you mean by an embedding at a high level. When you have an unstructured data, the embeddings is a smartest way to convert this unstructured data into a structured string, and then doing ML on the top of it. There are a variety of applications once you have an embedding of your unstructured data. Typical applications are information retrieval, search, and those kind of use cases. So how you do this? So you use this custom Vertex AI embeddings, some parameters, and that's it. And here you say that if this is my text called it's time to learn LangChain, this is an unstructured text. And if I want to get an embedding out of this text, this is how you get it. So here is a sample. Okay. So embedding is 768 dimensional, and these are obviously these numbers may not make sense to you right now, but these are the smart embeddings, and there is a beauty of all this, and we learned it right from amazing theory from TF-IDF and what to work and many other aspects. Okay, so you have an embeddings. These embeddings can be used for further applications, right? So at a high level, just to get started, LangChain supports three types of models: LLMs, chats, and embeddings. And I've just shown you an example of, it's super simple, right? Just declare it as a chat Vertex AI, declare it as an, custom Vertex embedding, and just start calling it as embedding.query, pass your text, you get your embedding, right? So this is about the models. Let's move further. What we have next? The next we have is prompts, and I'm sure you are aware of what do you mean by prompts, right? So there is a whole new area which is getting huge popularity is called as prompt engineering. So LLMs are pre-trained, but it is an art to get the desired output from your LLMs, right? So for that, you should learn the art of designing the prompts and all that. Okay, understand how these prompts are used in the LangChain, right? So for example, if I'm saying that I really want to travel to Pune, what should I do there? Respond in short sentence, right? So this is my prompt. This is how a prompt and how I'm doing it. So in an LLM, if you see here, I was actually sending a real query to this. So instead of that, the sophisticated way of doing that could be I will write a prompt and then I'm saying that LLM of prompt. So this will be given as a query to an LLM. And I'm saying that I really want to travel to Pune and what should I do there? And I'm explicitly saying that, respond in a short sentence. So it is saying that, hey, you can visit to Aga Khan Palace, which is a UNESCO World Heritage Site, right? Now the question is, tomorrow, if I want to change this to some other city, right? So instead of Pune, if I want to go for Mumbai, right? So I have to go there and I have to write here as an Mumbai, right? I really want to go to the Mumbai. And then LLM will be giving me that, hey, if you're going to Mumbai, then you should visit Gateway of India. As a programmer, you will understand that, hey, is there any way to parameterize this? Because when I create an application, nobody gonna go and write within the code and changing the prompts, right? So the beauty that LangChain is providing you is called as a prompt template. So from LangChain, you can import prompt template and how the template looks like. So in a template, you say that I really want to travel, and instead of hard coding, you can actually provide that location and what should I do. And now immediately you will find the value out of it. So I'll say input variable is location. You can have multiple input variable also. This is I'm defining as a template. So my prompt is actually I'm creating from prompt template is defined, how many variables that you want to pass. And once this prompt is actually set, you can say that my final prompt is, I'm just saying now here, instead of Pune, Mumbai, and this is completely parametric, you can type Goa and you just fire a query to LLM. And now see that what is your final prompt, what actually goes within LLM is I'm printing here, like, I really want to go to Goa. What should I do there? And ask to respond in a single sentence. So what is an LLM output that I got is you can go to the beaches, visit to churches and try a local food. Isn't this amazing, right? So soon you have realized that, wow, I can imagine now if I'm having some interface, this is how I'll take user input and then I create a prompt and then I'll ask the LLM and I'll get the answer back, right? So this is all about the prompts, okay? Now let's move to a very interesting one more component in a LangChain, and that component is called as example selectors. What is that example selector? So those who have some basic understanding of prompt engineering, one of way of doing prompt engineering is called as a zero shot learning. You just ask a question saying that, tell me what should I do in Goa, and you got an answer, right? But in some cases, it's called as few shot learning. In few shot learning means you give some sample to an LLM to get a context so that it will understand what you want to do. So here I'm giving an example, okay? So I'm saying that, hey, I'm giving few examples. You figure out the relation between it, and when a user fires the query, it should give me an answer, right? So I'm saying that when you get a word pirate, you should uh, you should return me a ship. If the input is pilot, you should give me a plane. If an input is a driver, the output is car. If I give a tree, the output is ground. If a bird, the output should be nest. So these are an examples. Now understand this: when you fire any query to large language models, you have limitations on your input tokens. In some of the models that you have, they are charge you token basis or on a character basis, right? So when you're working on some of an example, this few short examples can grow really long, right? And if you have so many examples within your prompt when you are sending a query, it has a direct relation with the amount of money that you're gonna spend, right? So understand the intelligence here, right? Based on the user query, there should be some intelligence that, hey, for this kind of an query, I may not need all examples to be included in my prompt because I want to save on the tokens, right? So that's why LangChain provides you amazing, it's called semantic similarity example selector. Means what? First of all, what you need to do is define all the input output relationships that you want to be exposed. And then what you do is you say that this is an example selector, uh, how what embeddings you want to do, how you want to save it, and number of examples to produce, right? So with this, what it does is when you few short prompt template, what is your template here? You are saying that give me a location and items as found in, and then you are saying that you will get some input from the user. Now please understand that what are my examples? Pirate ship, pilot plane, driver car, tree ground, right? Now at the time, if I'm passing an example saying that now you give me an answer for the student. Now for a student, understanding the meaning of word student and semantically similar examples into my this set, it is choosing which examples should go along with my prompt. And when I actually call this, you get an answer. So understand this is the prompt that goes, and it's saying that now from this, for the student, answer that get is a school, right? So amazingly, you don't have to worry about the amount of costing and tokens and all that. This is a way for you. Again, this is smarter way because it's kind of a dynamic, right? You don't know what end user will fire, right? So again, I don't want you to write a glue code saying that, hey, if input is like this, choose this example. If input is like this, choose this example. Rather than that, let LangChain choose that for you. I really like this feature. Okay. So this is about example selectors. Let's move to an output parser. So how many of you have actually tried LLMs to see an output, right? Have you tried to integrate LLMs with some other applications, right? For example, if you're passing some text, you want LLM to create some structured output out of it. I'll give you an example. Suppose the input to your LLM is a customer review. Okay, understand this use case. The input to LLM is a customer review, and you are not interested in all other text. What you want to extract is customer is talking about what product and whether customer review was positive or negative, right? So imagine, given a raw text, you expect LLM to generate a structured data or a JSON file, which will say that product is equal to XYZ, review is positive or negative, right? Now, if you spend a lot of time doing prompt engineering, can you give me guarantee that always the output that comes from an LLM is always in a well-structured format so that you can directly integrate with other applications and all? No. Sometimes you'll say, hey, I got a JSON response, but there are no curly braces. Hey, I got a JSON response, and the LLM just missed double quotes for my keys. Hey, I got a value, but there is no comma, right? So these small things, you can't keep on writing your own custom parser on Markdown output coming from LLMs and all that. There's so many issues that you may face into this, right? So don't you think there has to be something already created who will take care of all these issues? on the output from an LLM. And for that, you have an output parser, right? So what this output parser does is, understand this. So I'm showing you one kind of an output parser. If you go to LangChain um, uh, documentation, there are so many. Okay, so for sake of discussion, what I'm doing is I'm saying that from LangChain response schemas, I need a structured output parser, and I'm saying that you have to tell that how your response schema should be, right? So you're saying that when I say bad string, there is a description about it, that this is a poorly formatted string. So the application I'm showing you that if somebody is writing some query, before you start actually passing it to a natural language module, you want to make sure that it should be an error free. There should not be a typo there. There should not be spelling mistakes and all other aspects. Okay, grammatical mistakes, all kind of mistakes, right? So you'll see that I may get a bad string. So this could be a poorly formatted input from user, and what I want is a good string. So this is your response, a reformatted. So this is a structure I'm asking that LLM, you will get a bad string and you need to give me a good string. Okay, you need to just define the structure. See, this is a place where you can instruct LLM saying that, hey, I want a JSON output. The keys should be this and value should be this. So here is you're showing you what kind of a schema that you want. Once that is done, you can actually see that this is how the schema would be. I want output should be something like that: JSON, bad string, actual string, good string, and all that, right? So how I'm saying that, what is my template? You will be given a poorly formatted statement, instructions are given, I will give you user input, and what you need to do is your response, right? So understand this. So what I'm doing is, now this is, there is a mistake in the spelling what I have written. So look how badly the spell that I have done. When I actually run this, understand what kind of an output that you could do. So this is a markdown output, and you can actually see that. Look at this, a beautifully structured output. So when you give a bad string like this, you get a good string out of it. There are many applications which you will encounter when you are actually working with this kind of an output, because see, unless you will get an output from LLM, but I'm sure you don't want to write your own parsers and take care of the mistakes that are coming up. Here is, sometimes you get \n \t, and right, the bad JSON issues and all that stuff. So output parser. So I really like this, and I use at a lot of places, and it saved a lot of my headache of worrying about what if the output from my LLM is not good and all that. Okay, let's move on. So far what we have seen is, we have seen the prompts, we have seen the parsers, we have seen the models. Now let's understand an amazing aspect of the LangChain, and this aspect is called as a memory. So looking at the clock, I'm moving a bit faster. So by default, LLMs or chat models are stateless. Okay, stateless means they treat every incoming query separately. So what last few questions that you ask has a no impact on the answer that is provided right now. Okay, now you can immediately see that, whoa, even chat models are like that, but I don't want to do this. So you now people are trying to use LLMs in everywhere, like customer interactions and then smart bot and autobot and all that, right? The moment you come into a chatbot kind of a situation, it is essential for you to remember the previous interactions, right? Okay, if that is essential, how am I going to do it? Now, are you going to save it all that by your own, like, okay, this was my first question, I'm doing that? Absolutely not. I'll just show you an example, and after that, I'm sure you will really, really appreciate this feature of a LangChain. Let me show you an example. First, what if this kind of a feature is not there? What would I have done? I'll just showing you. I'm chat model. We have already defined chat model. What is my human message? Human message is hi. So I'm just starting a chat application and saying that, hey, What is the response for the hi? The response for hi that I got is hi. How can I help you today? That's good. So I'm asking chat model, obviously, what is my name? So this is first thing that I'm doing it, and I don't expect chat model to understand. These systems are not that smart to understand it. Okay, I'm okay saying that, hey, I'm not sure I understand what's your name. Now I'm telling you, hey, my name is Bhushan. Okay, so the response from chat model I got is, hello Bhushan, how can I help you today? Okay, now I'm asking you, okay, I told you my name is Bhushan. What is my name? And then the response that I got is, I'm not sure I understand. Okay, so this could be some kind of a dumb bot who is not understanding the context, who is not remembering what I'm saying. And in an old age chat bots, you must have received this, you must have heard the feedback from end users saying that, hey, your bots are not really understanding what I'm trying to say. How many times I supposed to say this is what I want, and those kind of a feedbacks, right? Now, let's see how easy by using LangChain to do all these applications. Okay, LangChain provides you three different types of handling memories. I'll come to that, but let's see uh, it is in action first. And once you get convinced, probably we'll discuss the nitty gritties of that. So what I'm doing is from LangChains import conversation chain, and I'm saying that buffer memory. Just not worry about this big name chain buffer memory. I'll explain you what it is. For now, just sit back and relax. What I'm doing is I'm saying that use a chat model, and in a memory I'm just saying you use buffer memory. So that's a small thing. So I'll just say that, I want to do a conversation. Now let's see after doing this how a same model is behaving for me. Okay, conversation dot predict. Now I'm saying that the same set of question, hey, what is my name? Okay, obviously the response that I'm getting is, hey, I'm not sure what your name, can you tell me your name? Okay, now I'm saying that, okay, my name is Bhushan. Now I'm telling you, so saying, hi Bhushan, nice to meet you. Okay, and now I'm asking all other questions like, hey, tell me what is 5 plus 6 and blah blah blah, tell me who is Sachin Tendulkar, all other discussions about it. And after doing all that discussions, I'm asking the question to the bot now, hey, what is my name? And now it is saying me, your name is Bhushan, right? That's the beauty of memory. Now, can you imagine if you were not having this kind of, look, it's a matter of two, three lines, right? Imagine without LangChain doing this kind of an application on your own, lot of pain, right? Every time you have to remember that, you have to append those plants together and all that. Okay, instead of talking, let me actually show you, what LangChain is doing for you in the back. So instead of verbose is equal to false, let me call it true. And now let's see. Now I'm saying that, hi, what is my name? Obviously, initially it will not tell you. Now understand how the prompt is getting improved. Because I'm using conversation chain with memory, so it is saying your my current conversation, human said, hi, what is my name? And AI responded saying that I'm not sure what it is. Then I'm telling you my name. Now, if you see that my prompt is getting bigger and bigger, it is actually saving it, saying that my current conversation is, hi, what is my name? I'm not sure. And now it is saying that my name is Bhushan. So now it understand, okay, user has responded, my name is Bhushan. Now I'll keep doing my other tasks. I'll ask other questions. I'll ask who is Sachin Tendulkar. And when I go back, and now I ask this question, what is my name? You'll see that it is responding saying that your name is Bhushan. Why? Because this all is in memory now. And in the back, it has learned that human has responded, my name is Bhushan. I don't think so. I need to discuss anything to convince you why this is important, right? Almost every chatbot kind of an application you will be needing. Okay, I'm sure there would be few people sitting back and thinking about, hey, how long this will go, right? You can keep chatting and chatting, and your this prompt will grow, and all that stuff, right? Eventually, as I said, more tokens, more characters, you need to pay more, right? So LangChain is taking care of that for you as well based on your application. You can choose what you can choose. You can choose, you can say that window memory. So instead of just buffer memory, you can say that conversation buffer window memory. Window memory means you can actually mention a number saying that, hey, you remember last 5 conversations, you remember last 7 conversation, you just remember last 1 conversation. So simple, just mention that and it will do it for you. Or if you're really sensitive about number of tokens, the, the amount of money that you're paying per token and all that. So instead of giving buffer number of conversations, you can actually see that till you don't get these many tokens, don't stop. And once you exceed, then you remove the older ones. Fantastic. So simple and so easy. And again, I'll see that you'll see these applications, right? I hope you all are convinced the beauty of the memory. There is a lot to it, but as I mentioned, the goal is to just give you the glimpse of the beauty of this LangChain, and then you're all open to explore and do your innovations on the top of it. Okay, so far we have covered models, we have covered prompts, prompt templates, example selectors, we have seen memory. Now let's come to a very interesting aspect of the LangChain, as the name suggests, chains, right? So why we need chains? So whenever you are developing complex applications, I think we have already discussed in the beginning of this session that for complex application, you only one LLM call is not enough. You need multiple calls. You need to take help from other components. You need to, the have connections outside it. So what chains does it for you is, it drastically simplifies your application development through composability, modular implementation, and you will see that it is much easier to debug, maintain, and improve your applications. Without much ado, let's actually see this core concept of LangChain with a sample demo. Okay, let me show you what LangChain has to offer for you. So chains. Uh, there are many applications where you will find that these chains would be very important. Let's get started with a very simple kind of a chain. Okay. Uh, what you need to do is first you need to say that from langchain.prompts you need prompt templates, and from langchain.chains you need LLM chains. That's it. So how a most simplistic chain would look like? The more simplistic chain would look something like this. You're saying that chat prompt template, you know, write a small blog on a city. This is my example. And I'm just saying that, hey, LLM chain, what model I want to use LLM and what prompt I need to do. That's it. So that becomes my chain. And how to run a chain? So this is so simple. Just you have to say that LLM chain. Within that chain, I'm saying that what is the model, what is the prompt, and just city is equal to Pune is my input that I'm getting from user. And when I write chain.run, it will write a small blog on a city, Pune, right? Uh, I think nothing complex here, but what you are saying is it's the simplest chain here, right? Now let's understand a sequential chain. Okay, here is a very important stuff. So what I'm trying to do is first I want to create a blog for a city. Once that blog is created from LLM, I want to create a summary out of that blog. So understand that I have a one chain which will generate a blog, and I have another chain which will summarize my blog, right? And there are infinite applications that you can imagine. You can have a first chain to get a user feedback, and then you can have another chain to extract entities out of it. Then you have another chain to create some response or some action on the top of it. So understand how the sequential chain goes. You have to define a simple sequential chain. Chat prompt template. So this is my first chain, and I have already discussed you how to define a simple chain. So this is my first prompt. This is my chain 1 and understand how my chain 2 looks like. So my second prompt is write a small words on a blog post. Now, from where this blog post will come? Actually, my chain 1 gonna write a blog post. Understand this, okay? I hope you understand the flow. The city will come from user. Once you get that, chain 1 will execute and create a blog. That blog would be given as an input to my second chain, and then second chain will generate a summary out of it, and at the end user will get an output. So I'm defining chain 2 here, and then look how I'm compiling. I'm saying that my overall simple chain is what? This is my simple sequential chain. How many chains I have? So I have chain 1 and chain 2, right? I have not done anything else. Chain 1, chain 2. That's it. Here I'm defining the sequence in which it should get executed, and that's it. And then I'm actually executing a chain with verbose is equal to true. You'll see that I'm entering into a chain because this verbose is true. This is an output that I got. Pune is a city in Indian state of Maharashtra. So this is complete blog created my first chain, and that goes as an input to my second chain. And this is the summary in a different color. You're saying that that is an output of my second chain, and this is the final output, right? Isn't it beautiful? Like, there could be a one chain which will do a retrieval operation for you. There would be another chain which will do summarization for you. There would be another chain which will do entity extraction on the top of it. There would be another chain which will create the desired output for you, and then you complete your applications. That's the beauty. Okay, I hope you understood the power of this chain, and doesn't necessarily be sequential. You can have routing chains also. With interest of time, I leave it for you to explore that way also. But in many cases, you'll see that you want to do one by one sequence of operations, and your job is done. That's the beauty of chain. I believe you really liked it. Let's move on to the next component. And the next component for us is called indexes. Now, um, as I said, when you create a complex application for LLM, the central box would be LangChain, right? And when you come under the component called indexes, the first module that you have is called as document loader. Okay. Now, here is a page called Llama Index, and that is open here. See, these all are the connectors that are available to load your documents within a LangChain. Isn't it great? You have a Confluence interface, you have an Asana interface, you have Chroma DB interface, you just name it, right? So from all these different places, you can bring your data. Trello is there to your LangChain. Just by looking this, it's already there from WhatsApp, Wiki. You just name, like from all these places, you just need to fire a single query called document loader, and it will bring data within LLM. Amazing, right? I'll show you the case study as we go. Text splitter, you have like, because right? For all LLMs, you have a token limit. So your entire document cannot go within a single prompt, right? So you have to split your documents. Again, no need to do manually. LangChain will support you to split your documents either by character or by token. Just you need to mention, hey, these are my bigger documents. You split them small based on these many characters or these many tokens. Once you have small documents, obviously you'll pass it to an embedding API, and then you have vectors. So where do you save those embeddings, right? So it has support for storing those embeddings into vector stores. It can store locally, or it can store to Elasticsearch, Cassandra, Vertex AI matching engine, Meta FISS, and the list is growing day by day. Look at the beauty. Take data, load documents from anywhere, split them, create an embedding, store it in some other vector store, and then retrieve it by using some logic, retrieve it using KNN, TF-IDS, AWS Kendra, a lot of applications. I think this slide will tell you like, wow, You can take it from anywhere, you can store it in any vector source, and you can retrieve it in any ways. Everything can be done by using LangChain. I'm not going to show a demo to this indexes because all these aspects we gonna cover when we go towards the case study, right? So let me show you a simple example. Let's say you want to build an application for uh, question answering, right? Now this all steps are involved. For example, again, this is, you can think of like an intra knowledge Q&A kind of an application. You have many documents, and as I discussed, this document could be anywhere. It could be in your lot of options that we discussed, right? So you want to bring those document, uh, you want to split those. Then once you split that, you have to create an embedding out of it. Those embeddings will be stored in a vector database. And this is an end user. End user will type a query. From that query, you have to create an embedding. Use this embedding for semantic search from vector source. Get the document closest search outcome, use it for LLM to do an answer and retrieve to the cell. This is a complete architecture of an intra knowledge Q&A, right? And all, look at the variables here. You can have any document source, you can have any way of splitting it, you can use any vector store, you can use any semantic search. Everything is supported by LangChain, right? So let me show you a demo, okay? So for simplicity, I'm just using LangChain document loader called PyPDF loader. I'm just taking one document from an internet. So this is Google 10K annual report, 92 pages, a big PDF file. And I'm just, look how simple it is. I'm just saying get documents that load. This is the URL, you get document from here. And it is actually taking document. We'll see the result. Now, what I'm doing here is once I get the document, obviously I said it's 92 pages document. You can use a text splitter, and I'm saying that chunk size 1500. So those would be the small chunks. So from 92 pages document, I have a small chunks, 263 small documents, each of chunk size 1500 is now created. Once that is created, as I discussed from this diagram, I have chunks. For every chunks, now I'll call a embeddings, right? Where I want to store those embeddings, LangChain.vector stored trauma. So it's a local database. You can use, as I discussed, so many options for vector store. And look how simple this call is. I'm saying these are all my documents. This is the way you have to create an embeddings, and everything should go into the database. That's it. It's a matter of one line, and it is doing all that job for you. It's going in a database. That's it. Now your database is ready, and now you want to retrieve it. So basis of what? Basis on similarity, you should retrieve how many neighbors? Closest two neighbors you have to retrieve. That's it. And then let's start using it. So in a LangChain, you have retrieval Q&A. What model? LLM model. And what retrieval you want to use? Document source we have already sent. You will just compose it and start firing the queries. These are your queries. See this? This is a query. What was Alphabet's net income? So my question was, what was Alphabet's net income in 2022? This was my query. And see, this is my answer. Alphabet net income in 2022 was this. Isn't it great? Now this is on my custom document. You can have your own document, just replace it. You can have all set of documents and use loaders, all PDFs together, split it. That's it. And that simple it is. Now to handle your latency and all choices are given to you. You can choose your vector store. You can choose your embeddings. You can choose your chunk size. You can choose your semantic search the way they want, right? That's how it is. Okay. So far, we have seen um, 5 things out of this. The last aspect, and probably the most exciting out of all, is called as agents. Now this concept is mind blowing. Okay, so far as as an user, we were owning the composability aspect of it. The whole control was in our hand. We are saying that, hey, you execute chain one, then you execute chain two, chain three, chain four. In chain one, do this task, chain two, this task. Yes or no? So this is all done by us, right? But what if you need some kind of a dynamic nature in your applications? You want an intelligence to your application based on the type of query someone is asking. It should be intelligent enough to choose the right tool to responding your answer. So if I'm firing a query related to math, it should use a different tool to return an answer. If I'm asking question related music, it should look for different tools, different sources for an action. Yes or no? Now, do you want to write that if else understanding? If the question is like this, you go here. If question is like this, go there. Or you want your application to be smart, to understand from user behavior what tools I should be using. That's the whole concept that you will see in the agents. It's really advanced. I'll try to give justice to it, but pardon me, I'll be showing some simple examples, but sky's the limit. Many things that you can do with an agent. So core idea, why you want to use uh, LangChain agents. So the core idea here is, so far we were just retrieving the things. Now we want some non-deterministic sequence of actions. I'm not i'm not designing do this after this. Not, I don't know what it turned out to be, what would be an answer. And I'm giving the power to agent to decide. Okay, and when I'm giving a power to the agent to decide what tools to be called, I want a reason, like why you took this call. So all the things that we learned so far were kind of deterministic, and the goal was to retrieve this. First time we are actually dealing with reasoning, why you did this, why not this. Okay, and this is going to be very very important for for enterprise scale application where reasoning is also equally important. So there are two types of agents. You will have an action agents. Action agent means at every timestamp it will decide on the fly what should be my next action. Based on the previous components output, it will decide on the fly what should be my next action. Those are called as an action agents. And there are other agents called as plan and execute agent. They decide full sequence of first. Still it is not hard coded. Based on a query, it decides, okay, I'm going to do this is. So it's plan first and then executes. Those are called plan and execute agents. So these should be used for a complex run-learning application. But for small tasks, you can use action agents. Like based on previous components output, it will decide, what should I do next. Okay, enough talking. Let me show you an example, and then probably you will appreciate the beauty of these agents. LangChain agents. Okay, so few inputs. Now come to here. Like what you need to do is, there are some predefined tools. So you can see that load tools is what I'm already defined. LangChain.agents import load tools. I'm saying that, hey, LLM math is a one tool. So that is already present in LangChain. I'm not doing anything. Wikipedia is one of the two. So I'm saying that, hey, I'm creating an agent which should take help of these tools, LLM math tool and Wikipedia tool, to generate the answers, right? I'm just defining what are the options for my agent while taking the response. Now, I'm deciding that, this is my agent, and let's see how it behaves. So I'm saying that you are an agent and you give me an answer like what is 25% of 300. How, like on the basis of what agent should take a call, what tools I should be using. I'm saying that Zero shot React description means what? From the descriptions of all these tools that I have written. So what is the description of LLM math tool? What is the description of Wikipedia tool? Based on that, you take a call. So this is my input query. Based on the descriptions of this tool, you take a call which tool to use to answer this particular type of question, right? So very beautiful. So when I ask this question, what is 25% of 300? I I run this, and now look at this. So it's saying that because verbose is 2, it is saying that the question asked is what is 25% of 300? It is saying that the thought, understand this, this is new for you because this is reasoning, right? What thought came? The thought, yeah, I need to use calculator to answer this question. So what action it takes? I think I should use calculator, and my action input is this. Once I know this is this, you got this answer is equal to 75% and final answer is 75%. That's the beauty. So from question, now you have thought, then you took an action, calculator, and then this. Okay. And then you obviously you got the what is the answer? Output is 750. Now let's give some textual kind of an input. Now look at my question. Tom Mitchell, Sir Tom Mitchell is an American computer scientist and a founder, university professor. And my question is, what book did he write? Now you need a factual answers, right? What book Tom Mitchell has written? And again, as I'm saying, this is a reasoning kind of a question. I cannot accept if your LLM is hallucinating and giving me some weird answer, right? In these applications, I'm actually using the reasoning aspects of it. Let's see the beauty of this. What is the question? The question is Tom Mitchell, American computer scientist, right? Based on the description, based on the query, it is saying that, hey, I should use Wikipedia for this. Okay, my agent took an action saying that I am looking for the Wikipedia. I will go to Wikipedia for Tom Mitchell. This is my action input. This has been derived. Tom Mitchell from Wikipedia. It got two people, one Tom Mitchell, who is American computer scientist, and another Tom Mitchell, who is Australian footballer. But we want Tom Mitchell as a university professor and artificial intelligence and academia and all that stuff. So the thought that comes is the book from Marshall Reed is machine learning. I got my final answer and you got the final chain. The answer is machine learning. Isn't it beautiful? Right? After using this kind of an agent, you can start trusting your LLMs. You can gauge the business trust that yes, we are ready to actually go for production kind of a deployment by using this. Otherwise, if you don't control, if you don't validate the truthfulness, it would be very risky to actually take these kind of a models to production. That's why it is very important. The last, I see that we are already on the top of our, we are already exceeding of time. Just one thing, till what you can actually extend this, you can actually write an agent saying that create a Python agent. Again, it is defined, you know, you can actually say that this is my sample list, and you can actually ask as sort this number. I don't have to write as, and it will actually, because I'm saying that you use Python for this, I just give a query. It understand that action is this Python. I know the input. I will call nums dot sort. This is done, and you actually got the sorted number out, right? Sort this number. See this, and then you got actually this is what all goes in the back, and you just don't need to do anything out of this. Just use LangChain, and it will take care of all that. You got your final output. So I think this is it. We cover all the components. I try to explain with different examples. These are the references that I use for creating this presentation. I'm seeing many people are asking about the URLs for this notebook for if they want to play. So I'll just uh, take the reference notebook that I've used to create this. I hope I should be able to share it uh, in the chat window for everyone. Uh, have a look at it, and I hope you'll enjoy playing this. That's it from my side. Thank you so much for your time. I hope you found it interesting. Is the memory maintained by LangChain or LangChain feeds old client into LLM for every new input? So LLM is okay. So as I mentioned, in a yeah, as I mentioned, in when you work on memory, uh, especially for chat application, there are three different ways by which you can actually ask to preserve it. See, eventually, the limitation here is about how many tokens you can pass in your next round. As I discussed, ideally all these models are stateless, right? So the what LangChain is doing it, saving your previous responses and generating a prompt so that the next answer should be should be given, right? So it's not that every new input that you have to show, it's a memory buffer. If you say that store only lasts these many tokens or save only these interactions or till my buffer gets full, this is how you can do it. Can it be done in Google Colab instead of using Vertex AI? I'm not sure if you have. Uh, I'm not sure. I think it is right. So this is the notebook. Yes, you can do it in the Colab if you have if you could have API. Yes, you can run it. Um, you don't need it. So do you need a GPU power perform all these actions? Not really. You're not doing actual extensive compute here. So what I've done right now is a simple small VM with a 4 GB of RAM, and I'm still doing it good. Yes, you can. Is it possible to connect to the databases? Yes, you can do it. The LangChain on private data centers. Yes, it is. You can use it, and the beauty is that if you don't want to actually. So there is a question from Ganesh like, is it possible to use LangChain on private data centers? So the type of a model that you are using, right? If you are using foundation models which require you to make an API call and your customer is not okay for that, you can still use few models which can actually run on-prem, as we discussed. Few models which are open source. There are Hugging Face local chains also. You can use that, so nothing will go outside. Uh, how to find vector store for another sensor? Yeah, so you can go to the LangChain documentation. They have currently supported so many vector sources that you want. So based on your latency requirement, the cost, and all that, you can choose what uh, vector store to use. Does PDF document stored somewhere, or it stays? Um, Yes, so if you're running it in locally, it will not store into document. But again, it's a type of the vector store that you use. You can use a local vector store also, so it will not go uninter. I understand the security constraints, and people are not happy to actually share this to outside. Can you share some areas of practical applications of LangChain powered application in market? Almost, almost like everywhere we are seeing. I'm not claiming that everyone is using LangChain, but I'm surely saying that in all applications that you are trying to do for now, at least one component of LangChain would be definitely going to helpful for you. Okay, I think I answered almost all these questions. Few of them are repetitive. If still I missed, feel free to reach out to me or an email. Thank you so much, Analytics Vidya, again for giving me an opportunity to share my thoughts. Thank you so much.